Hi everyone! In this tutorial we will go over a few frequently asked questions regarding color spaces in Scratch. Please make sure you watch the introduction to Scratch color management first to get familiar with how Scratch deals with color spaces in general. Here's what we will be looking at shortly. First, how to adjust the color space setting for multiple clips at once. How to manage shots in a non-standard color space. How to combine shots of different color spaces into a single composite. How ACES fits in Scratch color management. How to create deliverables in different color spaces from a single construct. And finally, how to disable Scratch color management. In the color management video tutorial, we already showed you that Scratch will read the color space setting from the metadata of the underlying media if that is available, and we showed you where you can adjust the color space setting of a single shot. Just to quickly repeat, you can use the metadata stack in the construct, or alternatively enter the player and go to the config menu. Now this works when you're only dealing with only a few shots, but not when you have to manage a large number of shots. Luckily, Scratch offers functionality to make your life easier. So here I have a number of TIFF shots that I want to load. Most TIFF shots, however, do not have metadata that tells Scratch automatically the color space they are in. If Scratch cannot determine the color space from the metadata, it will use the default project color space. In this case, the project default was set to Rec 709, as you can see here in the file browser. Now I happen to know that this particular set of TIFF sequences are in XYZ color space. So I can change the default color space here and then load them. Please remember that Scratch will only use this setting if the media you are loading does not have any metadata with the color space itself. If we now open one of the newly selected shots, you can see that it's flagged XYZ. An alternative way to update the color space of multiple shots at once is to use the media browser. When I simply select all TIFF shots that I just loaded and open the media browser, Scratch will keep the clip selection and I can go to the Grade tab and select an alternative color space. Next, I hit the Apply button to confirm the changes and done. So far, we've seen how Scratch color management deals with shots that fall into one of the known color spaces. But what if you have a shot that is of a different color space, or if you have your own transform, either in the form of a LUT or a CTL transform? Let's have a look at the following scenario. So here we have a ProRes clip from the ARRI Alexa. Of course, it's recorded in Log-C. Log-C is not a standard color space like Rec 709 or ACES, but rather something that was developed by the guys at ARRI and is optimized to store as much data from their camera as possible. So what should we flag this shot to? Looking at the drop-down list of available color spaces to flag a shot with, it doesn't mention Log-C at all. The most safe and accurate option is to use a LUT, provided by ARRI. Here I have a LUT of which I know it turns the shot into Rec 709 color space if applied. So let's go ahead and load the LUT inside the config menu. Now just flag the shot as Rec 709, because with the LUT applied, it actually is in Rec 709. An alternative approach would be not to use a LUT on the individual clip, but just work on the Log-C material and only do a conversion before display or render. For that, we remove the LUT here, but leave the shot flagged as Rec 709. This way, since our monitor is flagged with Rec 709 as well, no conversion will take place and we're actually looking at the Log-C media. Next, in the monitor settings menu, we add the LUT and make sure the Apply LUT button is enabled. This way, all our controls work on the Log-C values. One thing you need to be aware of in this scenario is that you also need to use the LUT on the output, so our renders are also properly converted. Let's go to the output menu. If we open the main output node, we can load the LUT in the config section. This way, we turn the log.c image coming from each shot into Rec. 709 in the main output node, and any derived output node will get true Rec. 709 media as input from here. As you can see, our image now looks a bit crushed. This is simply because right now we are doubling the effect, since we have the LUT loaded onto the output node to do an image transform, and also we still have the LUT active as a display LUT in the monitor settings. To disable the display LUT whilst viewing the output node, we can click the corresponding button in the viewport, or simply press F9 to see what my output will look like. One tip at the end of this chapter: if you're using any kind of LUT or CTL, please make sure to keep them all in your project folder so they can get easily relinked when the project is being moved. When you are compositing, you sometimes need to combine shots from different color spaces into a single composite shot. In that case, it might be necessary to first bring all clips into a single color space before starting the composite. Here we have a rather extreme example. Our background is an OpenEXR sequence in scene linear, whereas our foreground is in XYZ color space. Let's go into the player. Scratch by default interprets image sequences as linear. In this case, since there is no metadata providing the color space information, we need to set it ourselves. So let me flag the background to scene linear, so Scratch can do the right transform to display it correctly on my Rec. 709 display. Same goes for the foreground shot. Let me set the color space flag to XYZ to view it correctly. Now looking at both shots separately, all seems good. However, if we go to our background and add the witch on top, we quickly see that something's not right. This is because our base shot, the background, is flagged to scene linear, but the image we just placed on top is XYZ. So what to do? If we now change the color space flag of the shot to XYZ, the witch looks correct. Let me turn off the layer to have a look at our background. Now the background is the one that's off. As you can see, a clip simply can only have one color space. If we want to put two shots of different color spaces together in one clip, we need to first bring both into one single color space. So I'm going to choose scene linear as the color space I want to work in. Therefore, I switch the color space back to scene linear for the background. Now we just need to get our XYZ foreground into scene linear just before we add it to our composite. Let me delete it from the composite and select the source clip here. So first, we need to make sure the shot is correctly flagged as XYZ. Then hit the nest button below the layer stack. What has just happened? Let's swipe to the right and switch to the sources stack. Here we can see all sources and nodes that feed into a shot. Now the lower node here is our source shot we've been working on up until now, and it is set to XYZ. Now by clicking the nest button, we've told Scratch to wrap this source clip into another node, which is the above one. Now if I select this one, you can see the apply button right next to the color space selection gets active. This behaves the same as with the output nodes. If the color space of the source shot, which is XYZ, differs from the color space of the nest node, which at the moment is also XYZ, Scratch will perform a transformation. To initiate the color transform to scene linear, I will now switch the color space setting of the nest node to scene linear. As you can see, the image still looks the same. Don't forget, we have color management active for our displays, which causes Scratch to always display the clip in our display's color space, no matter what color space the source shot is in. So depending on whether we're on the source shot or on the nest node. Scratch always reads out the color space flag to display the selected node correctly on our display. Okay, back to our compositing. Now that we've brought our foreground into the same color space as the background, we can now go ahead and place one on top of the other. Let me quickly key the green screen so we can see both images in context. As you can see, both images share the same color space and can be composited on top of each other easily. Scratch fully supports ACES. Actually, in Scratch, handling ACES is no different from handling any other color space. To maintain an all ACES workflow, there are some considerations to keep in mind. First, Scratch provides the output device transforms. No input device transforms. These are expected to come from the camera OEM. Second, Scratch uses the standard output device transforms as provided by the Academy. If you have your own reference rendering transform or output device transform, you can adjust the CTL scripts Scratch uses. This is, however, an advanced subject and goes beyond the scope of this tutorial. Now let's have a look at this ARRI RAW shot. Currently, it is debired to Rec 709, hence it's flagged Rec 709 in Scratch. If I now go ahead and change the debiring to ACES, Scratch will automatically flag this shot as ACES. As the shot is decoded with the ARRI SDK, the proper ACES IDT is automatically applied. The next shot is also coming from the Alexa camera. In this case, it's not an ARRI RAW shot, but rather a ProRes file in log.C color space. Since this shot does not run through any SDK that could debire it to ACES color space, we need to do this with an IDT provided by ARRI. Please be aware that Scratch can create any color space out of ACES material. However, to do it the other way around, Scratch needs to be provided with the proper IDT, since these change from camera vendor to camera vendor. To apply the IDT, go to the config menu, click the load button, and load the CTL file, which will transform our image into ACES color space. Only thing left for us is to flag the shot correctly to ACES to have it displayed properly. Once we have our shot in the ACES color space, it is business as usual and Scratch color management can take over. Looking at the monitor settings, we can see that our display is configured to display Rec 709. So Scratch is doing the right conversion to display the ACES clip correctly on our Rec 709 display. Remember that this is just a viewing setting which does not affect our renders. Simply because our computer monitor is not able to display ACES correctly, we need Scratch to do a transform to Rec 709 first before sending the image to our display. Next, for the rendering. Let's have a look at our output node. I will leave the apply button activated, so Scratch will do a color space conversion on output if the output's color space differs from the clip's color space. Now setting this output node to Rec 709, Scratch will use the standardized reference rendering transform and output device transform to convert the ACES media to the Rec 709 output. Remember the color space setting of our output node. Well, there's not much hindering us from creating multiple output nodes with different target color spaces. The only thing to keep in mind is, as always, to keep the number of conversions as low as possible. To show an example of how not to do it, let's assume we have a construct loaded with ACES material, and so set our main output node to ACES as well. Now if we add another output to that one, and set its color space to sRGB, we are kind of shrinking the ACES color space down to sRGB. Simply because the sRGB color space is not as big as the ACES color space. Let's add another node behind this one and set it to P3. Now this is exactly what you do not want to do, because with the sRGB node, we are kind of clamping a good amount of colors of our ACES source node, which would potentially fit into the P3 color space, which is bigger than the sRGB color space. Let me delete this and load an output template I have prepared to show you how to do it the right way. So here's our main output node set to ACES, and so preserving the full color information. It is being fed into several output nodes in parallel. This one here is set to ACES, the next one is set to XYZ, and the last one is set to Rec 709. All those three output nodes get their color information directly from the main output node without being piped through several nodes with potential transforms. Further onwards, I have added other nodes to the tree, such as a burn-in plugin with QuickTime and MXF outputs downstream afterwards. Using this template, I can deliver for the VFX department with ACES OpenXR files, for a DCP mastering station with XYZ JPEG 2000 files, and broadcast or online review with my Rec 709 QuickTimes and Avid MXF files. I can add any of the output nodes to my process queue and start rendering each of them. Basically, Scratch color management is about two things: render and display. So if we want to turn off color management for display, we need to go to the monitor settings and disable the Apply Color Space button here. The second location where color management comes into play is the rendering. To turn off color management for rendering, we simply need to disable the Apply button right next to the color space selection on the output node. A third option, however, to disable all color management in Scratch by default is to use the corresponding variable to be found in the Advanced tab of the Preferences inside the System Settings. By activating this option, all color management functions in Scratch are disabled, meaning no conversion on display and no conversion on output is enabled by default. This leaves the user to bring everything into place. However, I strongly recommend to let Scratch do any color space conversion since, well, it couldn't get any easier. This concludes the tutorial about how Scratch deals with different color spaces. Please note that there are plenty of other tutorials available on our Vimeo channel as well as on Scratch Web. Bye bye.